Okay, welcome along then to these revision note solutions. So as always, we'll find these questions. They're going to recap all the work we've done over the last few weeks on shape. So I think this would be a calculator allowed test. So make sure you've got your calculators ready and we can take it from there. Okay, so first question, angles and parallel lines. So put that heading down and then have a go at these questions. Okay, so pause the video first and have a go at these questions. Then come back when you're ready for the answer. Okay, welcome back. So question A, we're asked to work out the size of the labeled angles, giving reasons for our answers. Okay, well, so here's the first picture. I notice that these two lines here are parallel. All right, so these two lines here are parallel. Okay, it's going to help me a lot. And now, well, I think the easiest one to do here is angle I. Angle I is obviously 102 degrees because opposite angles are equal. All right. Once you found an answer, remember, put it on the picture. Then I think I'll find, well, perhaps angle J, because angle J is, hopefully you can see, if I get my blue highlight maybe, see angle J, you've got two choices here. It's either a half turn here or here. I'll go for this half turn. And what do we know about angles in a semicircle? Or angles, remember, or angles, I said angles in a straight line, I suppose is the technically correct term. Remember, the target for a half turn is 180. So J is going to be 180, take away 102, which is 78 degrees, because it's on a straight line. Put it on the picture. Now, got H, G, and K left. I think I'll do angle K next. Angle K is 102 degrees. Are you wondering why that is? If I get rid of this blue highlight here, okay, then and go back and do the parallel line here. Remember, you can see it's 102 because this angle here and this angle here, they're the same shape, aren't they? These parallel lines are basically copies of each other, but this has just been shifted up here. So of course these two angles are going to be the same. They look the same and they are the same. Right? Remember though, there's a word for this, isn't there? Okay. Some people call them F angles, but the correct term is corresponding. And corresponding means matching or the same pretty much. Okay, so I'm going to use that version here. K is 102 degrees because it's corresponding. Okay, so K is 102 degrees. And now it's easy because you can see the angle H is obviously 102 degrees because it is opposite. Sorry, pen's got ahead of my brain there, sorry. It is opposite angle K. I know some people would say it's corresponding with angle I. That's also fine. And then G, well, again, can we see? You could use a half turn, or you could say it corresponds to 78. Either one. All right, I think I'll use corresponding because it's probably a bit quicker. All right, but if you did 180, take off 102, you will still get 78. So either way, doing that one is valid, and that one's done. Okay, question B then. Again, I'm going to highlight my parallel lines. Okay, here and here. And again, this one's a bit more complicated, but if you're stuck on angle rules questions, just work out angles, work at any angle you can, and then good things normally happen. See, I can't really find the angle M at the moment. There's nothing round by it, but I can spot a good old half turn here, a semicircle, a straight line. Okay, so I might call this one angle X because it's not known. I might say that, oh, angle X, look, it's going to be 180 take 139, which is 41 degrees because it's on a straight line. Put that on the picture. And now you spot, hopefully, that this triangle here is a special sort of triangle. This triangle here is an isosceles triangle. See, because it's got two equal sides. these hash marks mean the sides are the same. All right, and if those two sides are the same, remember, it means that these base angles here are the same. So I might call this angle Y and say that's also 41 degrees because it's in an isosceles triangle. And now the game's over because, remember, for a triangle, the interior angles have to add up to 180 degrees. So if you do 41 add 41, you get 82 degrees. And then so angle M is obviously going to be 180, take away 82, which is 98 degrees. And the reason for that is angles in a triangle sum to 180 degrees. So that is question 1 done. So question 2, interior and exterior angles of polygons. Again, pause the video and have a go. All right, then come back when you're ready. So work out the size of the labeled angles, give them reasons for your answers. Right, well, remember the key thing here, okay? Remember, interior angles in polygons are the angles inside the shape. So these are my interior angles here. All right, so remember you have to know, don't you, for these, what is the target number for the angles inside this shape? Well, you should have known by now, okay, because we've done it in previous lessons. Remember, it's all about triangles. If you count the sides, this shape here has got 5 sides, it's a pentagon. You count the sides and you take away 2. 5 take away 2 is 3. And that means that in this shape, there'll be 3 triangles. I'm not going to draw the triangles in because you should have seen it in a previous lesson and in year 8 as well. Remember, in every triangle, the angles add to 180 degrees. So 3 dots of 180 degrees on the calculator is 540 degrees. So that means for this pentagon, my target number is 540. So remember the usual trick then? Just add up what you've got. See, add up the 4 angles you've got. So I'm going to do 111 plus 105 plus 84 plus 98 gives me 398 degrees. Remember then, just take it off your target. So 540 take away 398 is going to be 102, I believe. I'll double check. Sorry, 102, 142 degrees. Remember, and that was angle N. So angle N is 142 degrees. And if you have to give a reason for it, you can just say angles in a pentagon sum, add up to 540 degrees. Easy. Okay, then shape B looks weird, but shape B is a regular hexagon. Remember that regular, if a polygon is regular, that means that all sides are equal and all the angles are equal as well. So in this shape, if that's angle P, I could also call that angle P, that angle P, that angle P, that angle P, and that angle P. They're all the same. Now this shape has got 6 sides. So if you take away 2, that means there's 4 triangles in this shape. Okay, and 4 lots of 180 degrees is 720. So the target for a hexagon is 720 degrees. Now there's 6 of these angles here, these interior angles, and they're all the same. So I need to split 720 degrees fairly into 6 equal pieces, which means I divide by 6, and that is 120 degrees. So angle P is 120 degrees. If you don't believe me, if you do 120 times 6, you will get back to 720. Okay, and if you have to give a reason, you can just say that angles in a hexagon sum to 720 degrees. Okay, job done. So questions C, D, and E. If you pause this now, these are about, oh, there's one more on interior angles, and then some on exterior angles. Okay, so question C is very much like question B, but there's no picture, and this time it's an octagon, right? Now an octagon, we should know, has got 8 sides. So I'm not going to draw a regular octagon and embarrass myself, all right? This is a regular 8-sided shape. So the same thing is going to apply, right? 8 sides. That means 6 triangles. All right, and 6 times 180 is 1080 degrees. That's my target for an octagon. But remember, there's 8 equal sides, so there's 8 equal angles. So if I do 1080 and I split it 8 ways, you get 135 degrees. So this is one interior angle. Is 135 degrees. Job done. Okay. Right then, question D is says find the size of the exterior angle of a regular pentagon. Remember, a pentagon's got 5 sides. Now you can do this in 2 ways. I'm going to do it a certain way to help us revise a key fact. This one, see, is not about interior angles, it's about exterior angles. And we should know from previous lessons, all right, that for any polygon, the exterior angle sum of any polygon, any 2D shape, is 360 degrees. Okay, so the interior angles change, all right, but the exterior angles for any polygon, you could have 3 sides, 16 sides, 4,000 sides, it doesn't matter. The exterior angles will always add up to 360 degrees. Now this pentagon's got 5 sides and therefore 5 angles. That means it's got 5 exterior angles. So to find one exterior angle, we would just take the 360 degrees and split it 35 ways, which is 72 degrees. All right, and that's that one done. And then question E, a regular polygon again has got exterior angle 36. How many sides does the polygon have? Remember, these are exterior angles, so I know my target is 360 degrees. And every exterior angle on this polygon is 36 degrees. So if I went around the polygon, I would have 36. If I add on 36 more for the next angle, that's 72. If I add on 36 more, that's 108. I'm trying to see now, how many angles? See, that's one angle, that's 2 angles, that's 3 angles. How many angles am I going to need to get to 360? Well, I think it's obvious that you could just do 360, couldn't you? You could count the 36s you need. That's 10 angles I need, all right, to make my full circle, to make my 360. It's got 10 angles. The question says, how many sides does it have? Well, if it's got 10 angles, then obviously it must also have 10 sides, because every side has got its own angle. And that's that question done. Question 3 then, dimensions. Pause it and have a go. Okay, then welcome back. Now, obviously, there's many ways to do this. I'll show you my method, but there are other ways to do it as well. So in this question, all letters represent lengths. Which of the following expressions give a length, an area, a volume, or none of these? Right, well, remember the trick here is to remember, right, that lengths are normally measured in things like centimeters, meters, etc. Areas, remember, are in square units, like cm squares, meter squares, etc. And volumes, remember, are in cubic units, like cm cube, meter cubed, etc. Okay, so if I'm doing question A, I always see this formula? I write it out longhand first of all. Now, 2x means 2 times x. The y is just there, and 3w means 3 times w. Now, remember, these lowercase letters are all lengths. So I always pick the simplest possible length my brain can imagine, which is 1 centimeter. So I pretend all the lengths are 1 centimeter. All right, that's my top tip here, okay? pretend they are all 1 centimeter. Then this would be 2 times 1 centimeter. That's that bit done. Plus 1 centimeter. That's that bit done. Take away 3 times 1 centimeter. All right, that's that bit done. Now 2 times 1 centimeter is 2 centimeters. This 1 centimeter is on its own, and this would be 3 centimeters. Now this one is slightly weird, okay, because you're going to get 2 centimeters, add 1 centimeter, take away 3 centimeters. That's 0 centimeters. So you might think this formula represents none of these, but it does. It's only 0 centimeters because I pretended they're all 1. If I pretended, for example, that this length here was 5, I wouldn't have got 0. And in fact, I'm sure you remember from lessons that all I care about in these questions is the unit of my final answer. Now I see this here is in centimeters. So I know that because the answer is in centimeters, it's going to be a length. So this is a length. Done. All right, that was part A. Part B, 3ab squared means 3 times a times, remember b squared means b times b. So again, this would be 3 times 1 centimeter times 1 centimeter times 1 centimeter. I'm pretending all the lengths are 1 centimeter. Do the numbers first. 3 times 1 times 1 times 1 is 3. And now for the centimeters, but I'm doing centimeters times centimeters times centimeters. That's going to be centimeter cubes because there's 3 of these in a row. Okay. So I see now this one's in cm cubes. So if I just highlight that in yellow, if it's cm cubes, then it's going to be a volume because volume is always in cubic units. This is a volume. On the last one then, part C, this means x plus y plus pi times r squared, and r squared is r times r. Now, if all the lengths are 1 centimeter, that's x add y. Now, really, for this, you can see the numbers aren't really important here. So I'm going to pretend pi is about 3. I know pi is 3.14159, etc. But for this, you can just pretend pi is about 3. All right? And r, again, is 1 centimeter. So if I work these out now, okay, 1 centimeter add 1 centimeter is 2 centimeters. And then this lump here, 3 times 1 is 3. And this time round, if you look at the centimeters, there's 2 of them. So this would be cm squares. And the problem is now, you look at this, what can I do with this? Nothing, because 2 centimeters add 3 cm squares. I can't simplify that down. You can't add together unlike units. So this formula cannot be converted into anything useful. There's no answer to this, all right? How do you add together centimeters and centimeter squares? You can't. So if that happens, you know the formula is nonsense. So actually this is none. All right, this is neither a length, an area, or a volume. It's actually nonsense. All right, you could say none. It's nonsense. It's a nonsense formula, okay? And that occasionally happens in the exam, so bear that in mind. That's that question done though. Question 4 then, Pythagoras' theorem. Pause the video, have a go, and come back to us when you're ready. Okay, welcome back. Remember, the most important thing with Pythagoras' theorem is the theorem. Remember, it says that a squared add b squared equals c squared. So remember, with these ones now, I'm going to try to do a separate line by here. Here we go on like this. For this one, remember question 1, the first step is to label the sides. This isn't actually a great question. The labels might confuse us a bit. Because remember, this side here shouldn't be called A. It should be called C. Because C is always the hypotenuse, the longest diagonal side. And A and B can be any sides you want, the other 2 sides. I always call the base B to remind me, B for base, I suppose. And that's A. Remember, write the formula down. I use the column method. A squared add b squared equals c squared. So a squared is 6 squared. which is 36. B squared is 8 squared, which is 64. Add those together, and you get C squared is 100. Remember though, I don't want C squared, sorry. I just want C. So remember, to finish off, you'll need to take the square root. And we should know that the square root of 100 is exactly 10 centimeters. Okay, then part B, again, this should be called C here. B, A, okay? So again, A squared add B squared is C squared. A squared is 6.7 squared. I have memorized this one. 6.7 squared is 6.7 squared is 44.89. B squared is 4.2 squared. I've memorized this one. It is 17.64. Add those together now to get C squared. So add 17.64 gives me 62.53. And again, this one, you'll need to take the square root of 62.53, which gives me the answer of 7.907, etc. Okay, it's a big long answer, so I'm going to round to 2 decimal places. You're going to get 7.91 meters to 2 decimal places. On to question C then. Again, bad labeling here, okay? This is C. I'll call this B, and this should be called A really, okay? Because it's the shorter side. So again, A squared add B squared equals C squared. This time round, look, I can't work out A squared yet. It's blank. B squared, though, is doable. 22 squared is 484. And this time I can work out C squared. 31 squared is 961. So I'm trying to think now, if I add this here to this, something add 484 is 961. Well, I just cheat and do 961, take away 484. Okay, that will tell me what I need there. So 961 take away 484 gives me 477. So A squared is 477. But that means that A is the square root of 477. And the root of 477 is going to be a decimal again, 21.84 kilometers to 2 dp. Okay, then question D. So actually, this question C, you might spot a little trickier, or maybe you might have known about a shortcut. See, if you're finding the longest side, we did an A and B, right? We were finding the hypotenuse. You add the two sides together, then you've got the squares of them. This one, to find the shorter side, you have to subtract the squares. A lot of my year 11 students have got a saying. They say short side subtract. If you're finding a short side, you subtract. So bear that in mind for the future, okay? And question D then, this one's actually awkward because it's not a right angle triangle. And Pythagoras' theorem only works for a right angle triangle. So this one, you might panic a bit, but if you're brave, you'll see that you can easily split this triangle into 2 right angle triangles. I'm going to work on the left hand right angle triangle, sorry. All right. Because there's a right angle here, you see? And I may even redraw this triangle by here, say, to help my brain see the bigger picture. Okay, so that's there. That's 70 millimeters. I'm asked to find D. Now this bottom length, okay, is not going to be 30. It's going to be half of 30 because I've halved the triangle. This is going to be 15 millimeters here, okay? So label your sides. C, A, B. As always, A squared add B squared equals C squared. So A squared, I don't know yet, all right? B squared is 15 squared, which is 225. And C squared 17 squared, which is 289. Again, right? Something add 225 is 289. So I just do 289, take off 225, and that there is 64. So a squared 64. So in this case, a is going to be the root of 64, which is 8 millimeters. And we are done. So question 5 then, speed, distance, and time. Pause the video, have a go, come back when you're ready. Thanks. Right then, so important thing about here with speed, distance, and time, I tend to use the formula triangle a lot. Remember the formula triangle? Your speed is distance over time. So like this, okay? And there's a time sign there in the middle. So question 8. Find this average speed. Remember, average speed just means the speed, okay? Who walks 10 kilometers in 4 hours. Okay, so for this one, my distance is 10 kilometers. And the time is 4 hours. Remember, find the speed. Speed equals distance over time. So that's going to be 10 kilometers. Make sure you put the units down over 4 hours. And that's going to give me 10 divided by 4 is 2.5. And the units, remember, are going to be kilometers because that's on top of the fraction per hours. All right, so I'll just say kilometers per hour like this. All right, and that's what the question wanted. Look. All right, so that's why I put the units in. So I know when I see kilometers over hours, I know it's going to be kilometers per hour. Okay, let's do question D then. Sorry, question D, question B. So this one, she drives 78 miles in 1 hour, 30 minutes. So the distance is 78 miles. And the time is 1 hour, 30 minutes. Find her speed in miles per hour. Okay, so 78 miles. I need miles on top because it's miles per hour. Now on the bottom, I need hours, just hours. All right, and at the moment, you'll see this time is in hours and minutes. That's not acceptable. We shouldn't we? An hour and 30 minutes. 30 minutes is a half an hour. So this is 1.5 hours. This actually is 1.5 hours. Okay, and if you do 78 divided by 1.5, then I'm pretty sure, I'll double check. I think you get 52, but I better double check. Yeah, you get 52. Right, miles per hour. Remember now, miles per hour, because it's such a common speed, people write it like this, miles per hour. Okay, they don't use the / notation, they just say mph for this one. See then, so James drives 120 miles from his house to a city. So this time I got the distance is 120 miles, and his average speed is 40 miles an hour. He left his house at 9:15. What time would he get to the city? Right, so I need to find the time it's going to take him. Now, if you look at the triangle, remember the trick here, if you're trying to find time, then cover up the T with your finger, your pen, or wherever. If you cover up the T, I'm not sure I can do this here, can I? No, I can't. If you cover up the T, you'll see that you end up getting D over S. So time is distance divided by speed. So this is going to be 120 miles over 40 miles per hour, okay? And this fraction is okay because I got miles on the top, miles on the bottom. 120 over 40 is 3. It's going to take him 3 hours because it was in miles per hour. So he left his house at 9:15. It takes him 3 hours more. So I believe that will be 12:15. All right. Now, I'm not going to say if this is AM or PM because this is in 24-hour clock time here, okay? That's 9:15 AM. This is 12:15 PM. This is 15 minutes past midday. Last one then. A man runs at an average speed of 5.3 meters per second for 16 minutes. The time is 16 minutes. Find the distance. Right, well, if you cover up the distance with your finger, you'll see the distance is speed times time. All right, speed 5.3 meters per second. And now you'll notice you can't put 60 minutes in for the time here because I've got meters per second here. So this needs to be in seconds as well. All right, now we should know, shouldn't we, that 60 minutes, there's 60 seconds in a minute, and 16 times 60 is 960 seconds. So this is 5.3 meters per second times 960 seconds. Put it in the calculator. Okay, so 5.3 times 960 gives me 5,088, well, in this case, the distance of meters. All right, this man's running quickly. All right, just double check I got that right. Yep, 5,088 meters. That is that guy's going fast. All right, so that's done. Okay, question 6 then. Pause the video, have a go, and come back when you're ready. Okay, welcome back. Remember, mass, density, and volume. Remember, these are connected by the equation density is mass over volume. So it's a lot like speed equals distance divided by time. So you can make a triangle again for this one. Density is mass over volume. Okay, and use it in exactly the same way as the speed, distance, time triangle. All right, so question 8. The metal's got mass 60 kilograms and volume 2.5 meter cubes. Find the density. Okay, now density is mass over volume. So that's 60 kilograms. Again, watch the units, over 2.5 meters cubed. All right, 60 divided by 2.5 is 24. And again, the units, look, are going to be, the units are going to be kilograms per meter cubed. All right, so 24 kilogram per meter cubed. And that is what the question wanted. Okay, so we are done with that one. I'll do part B here. So a second block of metal has got mass 54,722 grams. That's weird. And volume 8.2 meter cubes. I like the density. Well, okay, density is mass over volume. The issue here, look, it wants the answer in kilogram per meter cubed. That means I need kilograms on the top and meter cubes on the bottom. I've got the meter cubes, but I haven't got the kilograms. This is in grams, but we should know, it's a life skill, that about 1 kilogram is 1,000 grams. So going this way, you times it by 1,000. If you're working backwards, you would divide by 1,000. And I'm working backwards. So if you divide this by 1,000, you get 54.722. So 54722 divided by 1, 2. Just double check my work. Yeah, 54.722 kilograms. Okay, that goes here. And now you can work out the answer because the units are correct. So divide that by 8.2. You get an awful answer. So I go 2dp. I get 6.67 kilograms per meter cubed to 2dp. Last one then. Find the mass in kilograms of a cube. Volume 4.8 meters cubed. And density 0.6 kilograms per meter cubed. Right, so the mass, remember, if you use the triangle, if you cover up the M, you see that mass equals density times volume. So 0.6 kilograms per meter cubed multiplied by 4.8 meters cubed. And we're good to go, look, because these meter cubes match up. So 0.6 times 4.8 gives me 2.88 kilograms, which is what I wanted. So that's question 6 done. Okay, question 7 then. Pause the video, have a go. Is population density. Come back when you're ready. Okay, welcome back. And population density just means how crowded an area is. And the formula, I call it pop density for brevity. So the population density, remember, it's just the population of an area or a town or a city, for example, divided by the area the place takes up. And again, if you want to, again, it looks like speed, distance, and time to me. So if you wanted to, you can do, my triangle will be very weird here, okay? Population density is population over area, right? Very kind of like flattened triangle, but you know, the principle is the same. There's a time sign there as well. If you want to use that version, you can, all right? So question 8, the population, which I'll call, no, I'll write down population, of Newport is 151,000. And the area is 190 kilometers squared. So I forgot actually, what are the units of population? Well, the units of population is people. Find the population density. Okay, so the pop density is the population divided by the area. So that's 151,000 people divided by 190 kilometers squared. Again, watch those units, they're essential. And work it out. So 151,000 divided by 190 gives me 794.73 ... Now, we wouldn't round this to 2 decimal places because remember, we're dealing with people here, all right? And so really, I'm not sure if I should use a decimal, really, because population density means how many people there are per area. So I think, because I'm dealing with people, I probably would round to the nearest whole number. That's a 4 there, sorry. All right, no, it looks like that's a 4. So I'm going to say that this to the nearest whole number is 795 people. Okay, that is being rounded to the nearest whole number. Or if you're feeling flash, remember, whole number, the best word for that is the word integer. Okay, that's that one done. And then question B. So London's population density is 4,530. Oh, sorry, this is. Can I go back to question A again? 2 seconds, right? Remember, this was 795 people. All right, that's on top. Remember, though, sorry, per kilometer square. All right, that's my fault. Sorry. Remember, population density is people over kilometer squared, so it's going to be people per kilometer squares. My fault. Oops. Anyway, back to question B. The density of people here, okay, is 4,530 people per kilometer squared. London's area is very large, over 1,500 kilometers squares, almost 1,600 kilometers squares. Find the population. Okay, well, if I go by here, look, remember the population. If you look at the triangle and cover it up, you see it's actually the pop density, the population density times the area. So the population density is 4,530 people per kilometer square, and the area is 1,583 kilometer squares. We're good to go, look, because these two match up. And so if you do 4,530 times 1,583, you get an enormous number, 717 0.990. So 7.17 million, almost 7.2 million. Okay, and this one, all right, the population is a population. This one is measured in people. All right, and that's definitely right this time. So sorry for the error by here. All right, remember, hopefully you see why this is people per kilometer square, because you've got people on top of the fraction and kilometer squares under it. So that question is done. Okay, question 8 then, similar shapes. Pause the video, have a go, and come back to us. All right, remember now, and the similar shapes are shapes that are enlargements of each other. So shapes are only similar, mathematically speaking, if one shape is an exact enlargement of the other. So I need to find the missing lengths in this similar shape, for these similar shapes first of all. So I'm just looking, aren't I? Remember, I'm looking for the scale factor. So these two sides match up. So how many times has 25? Sorry, how many times has 10 been enlarged to make 25? Well, I think that 10 times 2.5 is 25. If you're unsure, remember, you can check on the calculator. You can divide the two sides. You do get 2.5. Okay, for these two shapes, the length scale factor is 2.5. All right, so that means now that to get y, see, y is going to be 8 times 2.5. Sorry, that 8's a bit shaky there, sorry. Y is going to be 8 times 2.5, which is going to be 20 centimeters. So y is 20 centimeters. Obviously, x, see, from the small shape to the big shape, I'm multiplying by 2.5. If I'm working backwards, I would have to divide by 2.5. I hope that makes sense. Okay, so it's 15 divided by 2.5, which is 6 centimeters. Easy. Find the length scale factor, you can't go wrong. Right, part B then, more complicated. So cuboid A has a volume of 24 cm cubes, and cuboid B is similar to cuboid A, but its dimensions are 3 times the size. Find the volume of the cuboid B. Well, for this one, an important thing we noticed in lessons, all right, that this question is dealing with volumes. We found out that the volume scale factor was equal to the length scale factor cubed. Okay, so if cuboid B has got dimensions that are 3 times bigger than the cuboid A, for this question, the length scale factor is 3. That means the volume scale factor is going to be 3 cubed, which is 27. So cuboid B's volume is 27 times bigger than this here. So that means that the volume of cuboid B is A's volume, but 27 times bigger. And 24 times 27 is 648 centimeter cubes. Okay then. So remember that this here is the key fact. The volume scale factor is the length scale factor squared, cubed, sorry. Right then, so these two cylinders are mathematically similar. The total surface area of cylinder B is 645. That should say cm squares there, by the way. All right, that should say centimeter squares. All right, because areas are always in square units. So the area of surface area of B is 645 cm squares. Find the area of cylinder A. Well, can we see that I've got these two matching lengths here, okay? So perhaps first of all, I could find the length scale factor. I'll do 20 divided by 8, all right? And 20 divided by 8 is 2.5. All right, so 8 times 2.5 is 20. Now, the volume scale factor is the length scale factor cubed. We also notice that the area scale factor, and this should make some sort of sense now, is the length scale factor squared. All right, so for this one, the area scale factor is going to be 2.5 squared, which is 6.25. So that means, right, that the area, perhaps I'll do it in blue to make it stand out a bit. The area scale factor is times 6.25. Now the surface area B is 645. See, if I'm working backwards, I wouldn't times by 6.25. I would divide by 6.25. Okay, so the surface area of A is going to be 645 divided by 6.25. I'm working backwards. 645 divided by 6.25 probably won't be. Oh, it's not bad actually, not bad. It's 103.2 centimeter squares. And that's that question done. Nice one. Question 9 then. I got surface area of spheres and cones. Again, pause the video, come back when you're ready. Okay, so question 8. A size 5 football used in the Premier League has got diameter 22 centimeters. Let me draw a picture then. Remember, a football is obviously, you know, a sphere, a ball, and it's got diameter 22 centimeters. But the diameter is all the way across from edge to edge to the center. Find the surface area. Now, in lessons we showed, all right, that the surface area of a sphere is 4 times pi times r squared, where r is the radius. So there's a problem here, okay? We are not given the radius, we've been given the diameter. Remember, the radius is halfway across. So I half 22, the radius is 11 centimeters. This here, okay, is the diameter. I need the radius. So now I can do it. The surface area is 4 times pi times 11 squared. Okay, so 4 times pi times 11 squared gives me an answer at 2 decimal places of 1520.53 to 2dp. Remember, because this surface area is going to be in centimeters squared. And then part B, an ice cream cone has the following measurements. Let me draw a cone. I know it's a cone, so remember, a cone, it's got like a circular entrance. Remember, it's like a party hat basically. Right, the radius is 3, so halfway across is 3 centimeters. Got you. The straight vertical height is 9 centimeters, and the slanted height here is 10 centimeters. Find the curved surface area. Right, now for a cone, the curved surface area, the formula we showed in lessons is pi r l. Pi times r times l. So we have to do pi times the radius, because r, see, this is r here. Remember, this is h, the vertical height, and l is the slant height. So it's pi times 3 times 10. For this one, we can ignore the height basically, okay? So pi times 3 times 10 gives me, pi times 3 times 10 gives me 30 pi, which is the 2dp, 94.25, again, centimeters squared. 2dp. Job done. Okay. Last question. I think this is the last one now. Yeah. So volumes of spheres and cones. Question A. Find the volume of the Premier League football. Right. So I think they mentioned that, didn't they, back in the previous question? Did they? Yes. Look here. It's got diameter 22 centimeters. Okay. So it's got diameter all the way across 22 centimeters. No props. Now, the volume of a sphere, remember, is 4/3 times pi times r cubed. Let me do that properly. Sorry, here we go. 4/3 pi r cubed. All right, where r is the radius. So I can literally do, can't remember, 4/3 times pi. Below r was not 22. Remember, r was halfway across. Okay, r is half of 22. R is 11 times 11 cubed. This will be a big number here. Okay, we don't let that put you off. So 4/3 times pi times 11 cubed gives me a large answer, 5575.28. Remember now, it's a volume, so it's going to be in centimeters cubed to 2 decimal places. Part B then, I got a 1 litre tub of ice cream. How many ice cream cones from 7B can I fill using the tub? Well, where's the cone then? There's the cone there. Let me redraw it then. This cone was like this, sorry, yep. Radius of 3 centimeters. Height of 9 centimeters, I believe. Yep, or height of 9, height of 9.5. I see, 9.5. So I made a mistake on the last slide. I put a 9. But luckily, I remember on question 9, we didn't have to use the height. So that's no problem. So 9.5 centimeters. Oof, good job I spotted that, wouldn't it? All right, and then this was 10 centimeters. How many cones will I be able to fill? Remember, if I'm filling something up, I need to know how much space, okay, I'm using up. And that is, remember, the space something takes up, the amount you can fit inside something, the capacity, this is the capacity, remember, capacity is completely the same as volume. So I need the volume of this cone. And a cone's volume is 1/3 pi r squared h. Remember this, the radius is r, h is the vertical height, L is the slant height. I don't care about L, about 10 here. I care about r and h only, okay? So it's 1/3 times pi times 3 squared times 9.5. So put that on the calculator. 1/3 times pi times 3 squared times 9.5. That gives me 89.54 cm cubes to 2dp. All right, now, see, I'm putting ice cream from a tub into my cone. How many cones can I fill? So I'm trying to see how many times 89.54 cm cubes goes into 1 litre. And the key fact to remember here, okay, is that 1 litre, sorry, is 1,000 centimeter cubes. So going this way, I'm multiplying by 1,000. Working backwards, I'm dividing by 1,000. So 1 litre is, I haven't even got to use the machine. 1 litre is 1,000 centimeter cubes. So I'm trying to see how many 89.54s I can get out of 1,000 cm cubes. This is a division question. If I divide these two now, so how many 89.54s can I get into 1,000? You get 11.17. All right, well, actually 11.16 it is. All right, 11.16. But remember, you can't fill up, can you, 0.16 of a cone, really. I think this would be 11 whole cones I could fill up. What assumption have I made? What have I assumed? Well, I've assumed that I filled every cone of mine completely to the top. All right. So I have assumed every cone is completely full. Job done.